In this lesson, we'll review some algebra concepts that relate to the coordinate plane. The coordinate plane is used to graph points, lines, and other functions. Recall that there are 4 quadrants, and they are numbered with Roman numerals. The origin is the middle, or the point with coordinates 0, 0. So the origin is the point with coordinates that are neither positive nor negative. Ordered pairs are written in the form x, y. The first coordinate tells how far in the x direction to travel from the origin. The second coordinate tells how far in the y direction to travel. For example, point B has coordinates -6, 4. So from the origin, we travel 6 to the left and then 4 up. Point D has coordinates 0, -5. From the origin, we travel 5 in the negative direction on the y-axis. Now, slope is the steepness of a line. We can also think of slope as the rate of change. In the case of the line shown on this coordinate plane, the line is decreasing, so the slope will be negative. We can determine the slope of a line 2 ways. Graphically, we first find 2 points that lie on the line. We try to find lattice points with clear integer coordinates. We measure the rise and the run between the 2 points that lie on the line. So the rise is -2 and the run is +3. Therefore, the slope, which is rise over run, is -2/3. There's another way to find the slope of a line. Algebraically, we could use a formula that helps us find the change in y over change in x. And here's your formula, which hopefully you'll remember from earlier grades. The coordinates of these points are listed, and we can substitute in the first coordinate as x and the second coordinate as y. We can pick either point to be the first point or the second point. Plugging in those coordinates, we can still get that the slope of the line is -2/3. Now let's think about midpoint. Midpoint is the middle point of a line segment. We can find it 2 ways. We see a line segment that's shown on the coordinate plane here. Graphically, we could measure the rise and run between these 2 endpoints and then take half of the rise and half of the run. So here's an example. Let's start at that top left point and go down 2, and then we go over 4 to the right. So half of those distances are going down 1 and over 2. That is our midpoint. We have an algebraic technique we could also use. Once again, labeling those 2 endpoints as x sub 1, y sub 1, and x2, y2. The formula we're going to use for midpoint is here. Numerically, all we're doing is we're averaging our x coordinates and we're averaging our y coordinates. So the average of the 2 x coordinates would be -4. The average of the y coordinates is also -4. Coordinates of the midpoint are -4, -4. Let's think about the equation of a sloped line next. Hopefully you will recall this, that the slope-intercept form is y equals mx plus b. And we use this form of the line when there is a clear slope that can be measured using 2 lattice points, and there's a clear y-intercept. So the slope is going to be down 1 to the right 2. We can follow that, and we see that the y-intercept is going to be -6. So y equals -1/2 x minus 6, where the slope is -1/2. How about the equation of a vertical line? A vertical line, as you can see, will have all of the same x coordinates. Any point that lies on that line has the same x coordinate. For that reason, the equation of a vertical line will start with x equals something. In this case, x equals -3 is the equation of this vertical line. A horizontal line will have all of the same y coordinates. For that reason, the equation starts with y equals something. We can see any point that lies on this line has a y coordinate of -2. The equation of this line is y equals -2.